Brownian motion. Let zt be a standard Brownian motion. Calculate the probability of the event that z1 is greater than 0 and z2 is less than 0. Hint is given to you, and then state the model for geometric Brownian motion and explain why the standard Brownian motion is less than the geometric Brownian motion as a model or the stock percent. So question 1. First is probability. So part 1. Alt equals to, given that z underscore 1 is equals to w, and we have to use z underscore z underscore 2 is equals to w plus x. So using this hint, we'll work. Alt equals to w0 is equals to z, and w is equal to z1 minus z underscore 0, which follows normal 0 comma 1 by Brownian motion, and alt equals to x is equals to z underscore 2 minus z underscore 1 follows normal 0 comma 1. Okay, since non-overlapping Brownian motion increments are independent, hence w and x are independent. Okay, therefore probability of z underscore 1 greater than 0 and z underscore 2 less than 0 is equals to probability of z underscore 1 greater than 0 and comma probability z underscore 1 greater than 0 comma z underscore 2 less than 0 is equal to probability of w greater than 0 comma w plus x less than 0. Hence alt equals to probability w greater than 0 comma x less than minus w. So alt equals to backslash int underscore 0 to the power w equal to 0 to the power backslash infty backslash int underscore x is equal to minus infty to the power minus w, when this is equals to f underscore w comma x comma w comma x dx dw. Come down. Then we have just copy this small portion where this is the joint PDF of w and x. Okay, since w and x are independent, this is equal to the product of marginal density function. So probability of z underscore 1 is greater than 0 comma z underscore 2 is less than 0 is equals to backslash infty. Oh sorry, I am not writing this w equals to this I am copying pasting, and then this becomes, since these are independent, so this will not be there. fwx, fww, and f underscore x dx dw, this will be there. Then this will be equal to backslash phi of w backslash phi of x dx dw, since both x and w are standard normal distributions. Okay, and then dealing with the integral with respect to x. So for calculating probability, this is equal to this part backslash of phi of w, then backslash capital phi of minus w. Capital phi will become cumulative and dw. So then coming next, this will be equals to open brackets minus of backslash of capital phi of minus w whole square divided by 2 brackets close underscore 0 to the power backslash I and f ty. Once you get this, so all equals to, this is equals to 1 by 2 backslash phi of minus backslash I and f ty square plus backslash phi of 0 square, which is equals to 1 by 2 into 0 plus 1 by 2 square, which is equals to 1 by 8. Okay. Third part is state the model for geometric Brownian motion. So that is equals to st is equals to e to the power w underscore t in brackets. Okay, and then you know the wt value, and then it is theory, so no need to do this. Coming to the last question of this paper. Describe the log normal model for securities of the definition. Again a theory question. State the corresponding mean variance. Theory question. The security price S is assumed to follow log normal. The price is now S0 equals to 200. The expected price at time 1 in years is equals to 200 e to the power 0.4, and the variance is variance S1 is equals to 40,000 e to the power minus of 0.4. Determine the parameter values for the corresponding log normal model. So question 2, this is question 2. This will become, we'll just do this mathematical plot. Expectation of S underscore 1 given expectation of S underscore 0 is equals to 200 is equals to 200 exponential of mu plus half sigma square is equals to 200 e to the power 0.4. Okay, and variance of S underscore 1 given S underscore 0 is equals to 200. then this is also equals to 200 square exp of backslash 2 backslash mu plus backslash sigma square into e to the power backslash of sigma square minus 1. So all equals to expectation of s underscore 1 given s underscore 0 equals to 200 to the power 2 into this value. It is equals to 40,000 e to the power minus 0.4. Okay, and once this is there, substituting 1 into 2, so we have 200 e to the power 0.4 square into e to this into sigma square minus 1 is equals to 40,000 e to the power 0.4. So this is equals to 40,000 e to the power 0.8 into e into sigma square minus 1 is equals to 40,000 e to the power minus 0.4. Okay, therefore backslash of sigma square is equals to ln of 1 plus e to the power minus 1.2, which is equals to 0.2633. Okay, and putting this into mu plus half sigma square is equals to 0.4. So therefore all equals to backslash mu is equals to 0.4 minus half sigma square. So equals to 0.4 is equals to 0.4 minus half into 0.2633, which is equals to 0.2684. Okay, so this completes this question as well. Thank you.